Hi, welcome to the first lab of the course. To help you begin writing your application, I'll explain some basic streams concepts and syntax. Let's get started.
In this section, you'll learn about how to construct a basic Hello World application. You'll see all the components that make up the application, including the Topology class, which frames your streams applications, data sources and sinks, which bring data into your application and write it out at the end, and submitting your application. We'll start with the Topology class. Essentially, all streams applications are flow graphs of data. Each application has its own topology and a unique data flow. The topology class contains the structure of the flow graph for your application. It also has methods to set up a data source for your stream. You must include the topology import from the module shown. Then, you can create a topology object for your application. In this example, the created topology is called Topo. Data source. The source function creates a new stream object from a given data source. You must pass your data source as input to the source function. For input, you must specify where the tuples on your stream come from. This data source must be a callable object that takes no arguments and returns an iterable. This could be, for example, a user-specified function that returns a list. In this example, the data source is a function called hwSource that yields a string hello world repeatedly. As you can see, hwSource is passed as the data source for the topology. Data sync. A data sync is used to terminate the stream and preserve its tuples to output. It can be seen as the end destination for the tuples on your stream. You must specify what you want to happen to the tuples after they have been processed. The sync function takes as input a callable object that takes a single tuple as an argument and doesn't return anything. The syntax for a general sync function looks like this. However, in this course, you will be printing output to the console and so can invoke the print statement to sync the stream, as is done in this example. There are a few steps between completing your application and running it. Once your application has been coded, it will first be compiled into a streams application bundle, or SAB file, which is the file containing the streams processing language code needed to run a streams application. After the SAB file is created, it must be submitted to a streams instance. Only then can it be run. This could either be a local streams instance or one on IBM Bluemix. This is a big concept in running streams applications. All you have to remember is that it's important to include a submit statement at the end of your streams program. There are several ways to submit your application. The first is over Streaming Analytics Service on IBM Bluemix. This option compiles and runs the application in the cloud on Bluemix. There is also an option to create a Streams Application Bundle or SAB file. This simply generates Streams processing language code and compiles it into a SAB file which can later be run from the Streams console. You can also submit as a standalone application. This option is best for debugging as it takes the least amount of time to run. Finally, you can submit as a Streams distributed application, meaning it is submitted to the Streams runtime environment on your local Streams instance. If your application is to share data with other applications, you must run it as a distributed application. Submitting it to Bluemix runs it in this way. In this course, you'll make use of the Streaming Analytics Service and run all your code on IBM Bluemix. To do this from DSX, you will have to include the import shown. You will also have to configure your connection to your Streaming Analytics Service. This segment of code will be included for you in the notebook already. Finally, you should already have specified your service name and credentials in the prerequisites section. Using these concepts, in this lab you will build an application that does the following. First, it will source its tuples from a repeated patient data sample. This is the sample you will be using. Then, it will print these tuples to the console. You'll monitor the application with the Streams console and build off it further in future labs. That's everything there is to learn for this lab. Though it's a lot to remember at once, this information will help you build a basic streaming application from scratch using the Python API. More detailed instructions can be found in the lab following this video, with a solution video to follow after that. Good luck!